Hello everyone, my name is Dan Bott, and today we're going to be discussing the impacts of climate change at 1.5 versus 2 degrees Celsius. So as we can see here, this is the abstract for the presentation. I'm not going to spend time going over this to save time for the presentation. However, please take a pause to read through this. So an outline for today's presentation, we're going to go over the history of climate change targets and define them of 1.5 and 2 degrees Celsius. Go over their different impacts and then what policies, where are we now and what policies are being implemented, citing a specific U.S. example in California, and then move on to what policies need to be further implemented before we wrap up with our conclusion, discussion, and references. So what does 1.5 and 2C mean as a climate target before we even jump into the history of them or anything? So it means a 1.5 degrees Celsius or 2 degrees Celsius increase in global average temperature compared to pre-industrial global average temperatures. Pre-industrial meaning 1850 to 1900, so before widespread industrialization. It's a delta. It's showing how much temperature has changed over time due to human factors. And this figure is here to kind of show that we are on track to surpass 1.5C by like 2040 potentially. So these targets, when they were made, their history is very interesting and important to understand how we can even achieve them. We're going to start off with that, discussing the 2 degrees Celsius target history, as that was the target established first. Climate change research started as early as the late 1800s and found footing in the 60s and 70s. And one of the initial debates was about what climate change mitigation targets should be. Are we targeting emissions, pollutant concentrations, temperature changes, rate of changes, etc.? There's a lot of things you could target for how we measure climate change and its progress. In 1987, the Bellagio workshop was the first to use the 2C target. Whereas, in 1992, the UN Framework Convention on Climate Change and the 1995 IPCC report were the first international policies to specify the 2C target. And that's when we really saw this take hold. And this target was made by a combination of politicians, scientists, and economists to find what would be possible globally. And scientists were skeptical of this target now and then, very importantly. Meanwhile, the 1.5C target has a little bit of a different history. It's the new normal for climate change targets, but it's a storied history. It was brought up in 2009 by the at the Copenhagen Conference by the Alliance of Small Island States, where they argued that the 2C target would leave vulnerable regions much more affected by climate change, and that 2C is an inequitable target on the global scale. There's regular debates on this until 2015, when the Paris Agreements formally adopted the 1.5C target. So this target was based more on ethics and political relations than necessarily science saying it was possible. The science backing for this is there, but a lot of it came later once there was funding and support for this more aggressive climate change target. So it's seen as a bit more unrealistic because a lot of the ways to hit 1.5C is with rapid technological developments and implementations, but it's a positive aspiration to work towards either way. So both of these have been met with scientific reticence and skepticism. So moving into the impacts of these different scenarios. At 1.5C, we're going to be seeing a variety of outcomes. I'll highlight a few here. So it's going to be hotter hots and colder colds generally. We're going to find, areas that are prone to heat waves are going to have more heat waves that are more intense. Wet areas are going to be found with more precipitation and it being more intense. So for instance, mid-latitude regions in the warm season will warm to 3 degrees C higher than normal. In the high latitude areas and in the cold seasons, it'll be 4.5 degrees Celsius higher than normal. There's going to be more invasive species and diseases and wildfires. Interestingly, there's going to be an ice-free Arctic summer every 100 years in a scenario such as this, approximately. Meanwhile, our oceans are going to have increased ocean acidification, more heat waves, reduced thermal gradients. They're going to be eroded, so there's going to be reduced ocean mixing and nutrient transport and continental climate moderation. And we're going to be seeing 70 to 90% of corals being eliminated. Organisms are going to have altered event timing, so things like reproduction and migration are going to happen at different times, affecting organisms' survival and life cycles, as well as their biogeographical ranges are going to shrink. 4% of vertebrates are going to lose about half their geographic range in this 1.5C scenario. For humans specifically, I'm going to sum it up with this concept of the human climate niche. And this is the concept that there are climates where human physiology and ecology thrive, leading to better societies and better human outcomes. And that's at 13C and about 27C. Those are the climates and temperatures where humans have the most ability to thrive, physiologically and ecologically speaking. At a 1.5C climate change scenario, 5% of the human population, or 0.4 billion people, will live outside this human climate niche. So humans are going to, die because of this and have varied, harsh outcomes because of it. So moving to 2C, it's essentially a nonlinear increase from 1.5C across the board. The effects of 1.5C are intensified and exacerbated with a 0.5 degree Celsius increase. The ice-free Arctic summers I mentioned before, instead of being every 100 years at 1.5C, are now every 10 years. We're going to get an extra million acres, not acres, I apologize, an extra million kilometers squared area of permafrost thawing between these two scenarios. From instead of being 70 to 90% of corals being eliminated, it's going to be 99% of corals being eliminated, harming ocean productivity and coastal protection as their ecosystem engineers, and that will harm the lives and livelihoods of millions of people. We're going to see ecosystems transformed. We're going to see organisms have less geographic range, as mentioned before, even more so in this 2C scenario. Head-to-head comparisons of these impacts, this is provided by the IPCC here. We're going to see, a sharp reduction in biodiversity due to species loss from 1.5 to 2C. We're going to be seeing more human heat-related deaths as climate change intensifies, and both scenarios, 1.5C and 2C and beyond, will lead to reduction in food production from maize and fisheries as shown here, as that color gets more intense. And I'm going to take a moment and zero in on this food production issue because climate change will drastically alter food security globally if it's left out of policy discussions at both 1.5 and 2 degrees Celsius. This is to go to show that climate change mitigation policies need to be inclusive and intersectional with how they deal with this problem. As of 2015, almost 800 million people were food insecure worldwide. In a 2C scenario, modeling scenario at 2050, without including food security issues into climate mitigation policies, 35% more people the food insecurity rate would increase by 35% to almost 900 million people. Food insecurity reduces in a 1.5C scenario, on the other hand, if modeling includes climate change mitigation policies with food security concerns, showing that we need to, include other issues when you talk about climate change. It's not just this one topic alone. It's not in isolation. It affects everything. And this is, in this example, tied to the fact that greenhouse gas emissions can increase the cost of food. Meanwhile, including domestic reallocation and international aid of funds for inclusive climate change policies is actually kind of a drop in the bucket relative to the total cost of climate mitigation. So climate change policies need to include concerns like food security for both 1.5C and 2C scenarios. This moves into where are we now and where are we heading with climate change. So we're going to get some very current events, like as of this month, recording this, November 2023. So as of 2023, we've achieved 1.1 to 1.2C global average temperature increase relative to pre-industrial times. The red lines here are showing our emissions with our current policies not slowing down, just kind of leveling off or potentially increasing as well, showing that climate change wouldn't be mitigated with our current policies and that we need to limit warming to 2C and 1.5C with vast and rapid and deep changes to how we interact with our industries and our emissions. So we need changes now, essentially. To kind of focus in on this, we briefly surpassed the 2C mark for 2 days in November 2023, which already was the hottest year on record. So 2 days in November, when I was making these slides, surpassed the 2C mark for 2 degrees Celsius hotter than pre-industrial times on the global average scale. So it's not the new normal or the new average, but it's the first time we've seen heat this high in November. And so it's a cause for concern and showing that our current climate mitigation practices aren't working. And I'm going to further zero in on this, despite it being a bit depressing. I apologize. But this month, James Hansen, who is a famed climate change scientist, released a new study detailing the current trajectory of climate change and scientific reticence, which I'll touch on the next slide. He argues that the IPCC estimates for sea level rise and ocean circulation shutdowns are vastly underestimated, that sea level rise and ocean circulation shutdowns are going to be worse than our predictions are saying. And this is tied into the fact that when you use modeling that includes climate sensitivity, paleoclimatology, emissions, and ice sheet changes, interacting within themselves and with each other, it leads to the result that the rate of climate change is increasing, which of course will harm sea level rise and ocean circulation shutdowns, which then ties back into it. It's an interactive model. And it shows that, climate change rates are increasing and we need to be more proactive and transformative with our climate mitigation practices and policies. The study shows that there's a potential to hit 8C instead of 1.5 or 2C in the current scenarios. This, of course, has been met with speculation and reticence by others because it's a harsh deviation from the norms, but Hansen actually discusses this in the article with the scientific reticence section. He asserts that a previous study was blackballed from IPCC reports and calculations censoring that type of data, and that scientific reticence, which is the concept that scientists have a tendency to resist, scientific discovery, new ideas, in order to be more proper, following the path of, getting enough data to believe a new idea. While that's important for some scientific communities, in climate change, being scientifically reticent can cause great global harm and human harm and ecosystem harm, and that scientific reticence needs to be pushed aside in climate change concerns. And I think that's a very interesting point when we look at the program we're in, we look at the science we're learning, and the policies that are in place. It really pushes on this idea of how much data do you need to make a change versus when can you make a change for these 1.5 and 2C scenarios that we've been talking about in this presentation. And this will come up in our discussion questions as well. But I think it's important to just note how impactful this is. So, what policies have been implemented so far? I'm going to use an example from California, which is the fourth largest economy in the world. They are working on implementing AB 32, which is an unprecedented in scale and scope climate change proposal to hit carbon neutrality by 2045 at the latest. It'll do this by targeting greenhouse gas reductions, air pollution reductions, cleaning up the air, and reducing the demand and use of fossil fuels and liquid petroleum. It'll create 4 million new jobs that are in the green sector, as well as saving Californians' healthcare costs, and utilizing proper construction and technologies that are climate friendly. And this is the type of rapid and transformative and deep policy change that I've been mentioning for the past few slides that we desperately need to hit 1.5 or 2C scenario based on our current conditions. So this is a good example of that. Furthermore, at local, national, and international scales, we need to be changing our energy supplies to things like wind and solar and potentially nuclear and geothermal, despite some cost issue potentialities here. It can be worked out and there's solutions to this, as well as the fact that we need to alter, how we use our land, water, and food, and create infrastructure in our cities and companies and organizations to be more efficient and climate friendly, as well as, how we deal with our waste. A lot of these technologies do exist. They just require proper implementation and incentivization. This is seen even at my small scale of transforming labs to be more sustainable. It ends up being safer and cheaper. So in conclusion, the targets of 1.5C and 2C were set as mitigation targets for scientists, economists, and politicians in the 90s and 2000s. And at 1.5C and 2C, we're going to be seeing increased extreme weathers, reduction in biodiversity, ocean acidification, food insecurity issues, and millions of humans living outside the human climate niche. And this will all exacerbate as you move from 1.5C to 2C in a nonlinear fashion most of the time. And we have already hit 1.1 or 1.2C already, and so we need deep changes now. while California and the U.S. have had some promising policies with AB 32 and Biden's Inflation Reduction Act, we need more than that, and we need it now. And that is through things that exist already as well. Important to note. I do have 2 call to actions here that I urge my classmates and those interested into following through on. So COP28 is happening later this week. It's happening, I believe, on November 30th, which is the UN Climate Summit. It was announced last night while I was finishing slides that President Biden will not be attending. Despite the Inflation Reduction Act, which is a 10-year, $370 billion plan, and the deal with China to reduce or increase renewable energy usage, we need more than that, and we need it now. So I'd urge folks to follow COP28, what happens, and see how you can interact with your local and national representatives to push for climate change mitigation policies and strategies. Also, on the same type of topic, President Biden just signed CP2, which is a new liquefied natural gas pipeline that would release almost 200 million metric tons of CO2 equivalents emissions yearly, which is 20 times the amount of emissions as the Willow Project in Alaska, which is already controversial. And so petitions are out to protest this project, as well as the opportunity to call representatives and things like that if you live in the U.S., and I would urge all of us to do that. Here are the discussion questions for this presentation. I appreciate your time there. And here are the references. Thank you very much, and I appreciate all of your time and interest.